A large dataset question here. Chart below represents the percentage increase, which they call MPI, in the numbers of employees using 4 different methods to travel to work from 2001 and 2011. 5 different local authorities in Wales. We're then asked to state with a reason which of the 4 methods of transport probably had the greatest overall percentage growth in these local authorities between 2001 and 2011. So we can see the work from home and driving a car or van. Okay, they've increased, but not by that much. It's where it gets darker that the increase has been greater. So underground or train. And whilst there's not much in it, the fact is that in Talbot, near Neathport Talbot, actually there's been hardly any. So they're looking for train. Train. I wrote train since the percentage increase is greater than 90% in 2 local authorities and between 50 and 90% in the other 3. Maybe I could have said whereas the underground has not much increase in Neathport Talbot. This is what the mark scheme said. Train because all increases are over 50%. That's quite a nice way to put it. So you must specify that. And you could talk about that up there, or that it's got the darkest colours. That was okay. Part 2 then says explain why your answer is not definite, and I said that we just don't know how big the local authorities are. There's no well, I said there's no information on frequency, but really it's like the size of the population. Okay, this is what else you could have said. The chart does not show where in the range each value is, so you could refer to it, because maybe the train ones are all at the lower end, well, 90%, and maybe some of the underground ones go above 100% because it's the percentage increase, so it could increase by over 100%. But yeah, you could also say we do not know the relative sizes, and there's some on the right that you could refer to as well. Maybe error. Oh no, you didn't get away with maybe errors in the data, but we do not know exact values because it's grouped. Okay, but you need to refer to exact values. Increases could be much higher than 90%. Low percentage of high numbers may be greater than high percentage of low numbers, that kind of thing. The student suggests that the chart can be used to estimate the total percentage change for these methods of transport in each local authority. So in each one, give 2 reasons why the student's likely to be wrong. So in this question, you don't get away with saying that we don't know the number of people in the local authority, because it doesn't really matter. It's all about the percentage change. So that's actually not relevant. What you can refer to is, again, that we don't have exact information on the percentage increase. So that's going to be an issue. And also, we only have information on the percentage increase, not actually about the proportions themselves. So the total percentage change, we might not have many people actually taking the train, which actually comes in later on. So, just because you can have a large percentage change doesn't, if you only had like 1 person taking the train and it doubles, that's 100% increase. But that doesn't mean there's going to be a large percentage change overall, because maybe like loads of people are driving, and we need, even though there's a lower increase, we kind of need to take that into account. If lots of people are driving and there's a small increase, then the overall increase is going to be small as well, rather than large. So anyway, let me show you the mark scheme. So do not know the initial proportions of each mode of transport. Do not know the exact percentage increases. So, and then there's some bits on the right that you could say as well, which is along the similar lines. But yeah, you cannot talk about the size of the local authorities. And also, you can't just criticize the data. And C, a student wants to investigate the trend from 2001 to 2011 in numbers using underground, metro, light rail, or tram. The actual numbers of people using these methods in the local authorities in 2001 were all less than 50, and in one case was only 4. So explain why this means that the chart does not provide very helpful information for the student. So I again went with just we don't have the number of people, but I think it wanted a little bit more. So it said that small changes in these small numbers will lead to large percentage increases. If you, my example of 1 person doubling, it's only gone up by 1 person, but it's been 100% increase. So yeah, if there's only a small number of people, then this is quite misleading, and you might think like lots more people are taking the underground when actually in reality they're not. And then finally, in D, it says, let D denote the number of people in the Vale of Glamorgan whose usual method of travel to work is driving a car or van. And let H denote the number of people in the Vale of Glamorgan who work mainly at or from home. Between 2001 and 2011, the increase in D was approximately 3.5 times the increase in H. Use this fact and the information in the chart to estimate the ratio D to H in 2001. I think this is a pretty awkward question, if I'm honest, but this is how you do it. Even though we don't know the number of people, we can still get the ratio, which is quite nice, really, from this graph. So, increase in D. Now it's this grey box here, so it's between 10 and 30%. So let's take the midpoint, just like you normally would with your group frequency tables and so on. So let's say there's been a 20% increase in D. That means the increase in actual numbers is going to be 0.2 times D. Remember, your multiplier is like 1.2 if you want to increase, but if we want the actual 20%, it's going to be 0.2 times D. And then we want the increase in H. H was working from home, and that's this box here. So it's going to be 40%. There was a 40% increase, which means the amount of people would be 0.4 times H. And that's what we need for this. Now we can say that 0.2 is going to be approximately, because that's the number of people who are driving, approximately 3.5 times the number of people working from home. We've got ourselves an equation. So we can divide, well, times through by 10. So 2D is going to be approximately 3.5 times 4H. I can divide through by 2, 2H. So D is approximately 7H. And therefore, the ratio D to H is going to be approximately 7 to 1. You can see that D is 7 times bigger, so it's going to be 7 to 1. Or you could, you can like, if it helps, if you're a bit stuck by that, then D to H is going to be it's going to be 7H to H, because I'm just replacing this by 7H, and then you can divide through by H, and you see here that you get 7 to 1. Okay, well done on this question. I think it's one of the more awkward large data set questions, if I'm honest.